This is the Convergent Science Network podcast. Leading researchers in the domain of neuroscience, brain theory, and technology are interviewed by Paul Verschure and Tony Prescott.
So this is Paul Verschure with the Convergent Science Network podcast, together with my colleague and co-organizer of the BCBT Summer School, Tony Prescott. And we're talking with Marco Diana, who is one of the speakers in our school this year. And Marco, you spoke on the induction of an hypodopaminergic response through transcranial magnetic stimulation. So the question is, how did you end up linking, if you want, transcranial magnetic stimulation in the treatment of addiction? Right. So what was the trajectory that kept you there?
Okay. Let me make this thing straight first. The hypodopaminergic state contains, or the hypodopaminergic hypothesis contends that the chronic use of drugs, several drugs, different drugs, alcohol, cocaine, opiates, psychostimulants in general, will produce a hypodopaminergic state. From here, you can give a reason or a possible reason to justify all the changes that you observe in a drug addict. Or not all the changes, but at least some change. As we all know, dopamine works in movement, is important in movement, is important in reward, is important in motivation, is important in a number of functions. The transcranial magnetic stimulation, in principle, may offer the cue by stimulating the prefrontal cortex. You can take advantage, or you can exploit, if you will, a well-demonstrated anatomical pathway which goes from the prefrontal cortex monosynaptically to the ventral tegmental area. And this neuron will impinge upon a dopamine neuron, which in turn will project to the limbic areas. So if I apply transcranial magnetic stimulation in a stimulatory pattern, I should, in principle, potentiate a system that has been functioning less due to the chronic use of drugs. Mm-hmm. In fact, these are already being shown in healthy individuals. If you do apply TMS to the prefrontal cortex, you get an increase in dopamine release, as shown by PET studies by Antonio Strafella, essentially, and others.
Right. So that's where you are today. But in some sense, we first have to inspect what is really the brain of an addict, right? How's the brain of an addict different from a healthy brain? So, and you very much emphasize then the role of dopamine.
Exactly.
And dopamine reconfiguration.
Exactly.
So how should we think of the brain of an addict?
There is another area that we did not emphasize today, but that requires and needs to be remembered. This is the prefrontal cortex. It has been shown by others, by the visual imagers, for instance, that the cortical mantle at various levels of the dorsolateral prefrontal cortex works less. I'm using very simple terms simply to be understood. For instance, Nora Volkov and Rita Goldstein They think that the lack of function, or the reduction of function in the specific orbitofrontal cortex, is then responsible for the impulsivity that characterizes the behavior of the addict. One of the key features of addiction is craving for the drug. It simply cannot resist. And so many indications and many reports suggest that this is due to a malfunctioning of the prefrontal cortex. Specifically, in their idea, is the orbitofrontal cortex. Other people think about the cingulate cortex. Some more think about the dorsolateral prefrontal cortex, also because in cortex there is a small problem. To identify, the cortex does essentially always the same things: cognitive integration, decision-making, working memory, and several others. But it's very difficult to find the borders between prelimbic cortex, cingulate cortex, orbitofrontal, dorsolateral, dorsomedial, ventrolateral. There are no a priori boundaries. And when we apply a stimulus like the TMS, it's very difficult to contain that stimulus only to the prelimbic cortex and not touching the infralimbic cortex, and so on and so forth. So the agreement exists on the frontal lobe of the brain, which is not working properly, and in many senses is unable to keep down pulsions. So is unable to avoid dangerous behaviors.
So that means, a good definition for you, addiction is also a pathology of executive control.
Absolutely.
So it's not only, let's say, as we'll see also later, excessive manipulation of a reward system.
No, absolutely not.
But do you see it as an independent process, or that is dependent on, again, what happens to
I think
the reward system?
The key is, suddenly the reward system is damaged. Let's put it that way. And suddenly the reward system responds immediately as the chronic treatment goes on. At the onset, the cognitive part will come into play later on. Does not have the same time scale, the cognitive part, as the emotional part. Emotions begin initially, take drugs, dopamine goes up, is happy, honeymoon. Then slowly the system adapts, and the second system, the cognitive systems, mostly the cortex, will become involved. In other words, in spite of the fact that you are taking drugs from time 0, at time 1, the limbic system is intervening and modifying your behavior. But at time 10, the cognition will come into play. The cognition means also that the addict becomes aware of the fact that he is an addict. He is an addict. It means he is a patient. He needs help. He needs somebody to rely on to come out from a situation that has slipped through his fingers, to put it in this romantic way.
Mm-hmm. Can we know for sure that the people that become addicted to substances are already predisposed in some way towards addiction, so that other people may be given the same introduction to these substances might not become addicted, but these people may already have some aspect of frontal cortex dopamine function which predisposes them towards this?
Now, there are studies, of course, which have indicated that there is a component, a genetic component, which will favor the emergence of the full-blown phenomenon.
Right.
It is a multifactorial disease, if you wish. I remember that a paper in Science by Yervi Piazza and his co-workers found that roughly of 100 people that will take drugs, roughly 17-18% will become addicts. Taking a drug does not mean to become an addict. The diagnosis is, it's very clear. The DSM-5 will tell you exactly that you need to take drugs. You need to take continuously. You need to make attempts to stop. You know that you're doing bad to yourself, so you try to make attempts. And these attempts to quit, they fail. Okay? Another very important point is the fact that at one point, the drug is interfering with your life. It's not anymore a matter of physical, biological problems. It's a matter of interference with your normal social life, which means working life, which means familiar life, which means social life, and many other things. So, of 100 people that will take a drug, roughly a fifth will become real addicts.
So now to bring that back to what you discussed earlier about prefrontal cortex. So on the one hand, there's this idea, and then we can also expand that later, that drug use, whether it's morphine or opioids or alcohol, is targeting the dopamine system and lead to a dysregulation.
It's one of the
right?
targets.
Exactly.
One.
Absolutely not. So that's not a debate yet, right? But now I could argue, well, but since dopamine is changing, the targets of the dopamine system, including prefrontal cortex,
Yes.
is also changing its response.
Exactly.
So the long-term changes are in the end a knock-on effect of manipulations of the neuromodulatory system. Okay? With an alternative interpretation is to say, and that's a bit, I think, the direction you were going, I have different functional subsystems. And these functional subsystems all have their own regulatory role in the control of behavior. And you might have, let's say, a limbic system dealing with issues of satisfaction of immediate needs and craving that it tries to resolve in some ways. But when that remains unresolved, I have to start to use, let's say, cognitive resource to resolve that problem. And that's how I start to engage my executive control system, the frontal cortex. So which of these two causal pathways do you see as being dominant in the development of addiction?
I don't see any one of those dominant. Probably if you stick a gun on my head and tell me only one, I will tell you about the cortex.
Mm-hmm.
Because another problem with the addict.
Take out the gun, Tony.
Another problem with the addict is a very difficult patient. All patients, they recognize their status as a patient. If I feel pain on my shoulder, I will come to you and I will tell you, I feel pain. Tell me what to do, what I have, or what I should do to fix it. The addict does not recognize that is a patient. And that elongates his pathology.
Mm-hmm.
He has to make efforts to realize that it needs treatment and seeks treatment.
So that form of anosognosia, or is it characterized differently?
I don't know, but I would say that this is a cortical problem.
Mm-hmm.
I wouldn't say that this is a dopamine-related problem.
Okay.
This is a
But
problem of cognition.
Okay.
Self-awareness.
Mm-hmm.
What am I? Am I an addict and thus the patient? Or I am simply a person having fun with cocaine and I'm rich enough and I don't care.
Mm-hmm.
For me, 3,000 euros every Friday is nothing.
Right. So would the distinction be that the addict is actually suffering from pathology that also deforms the self? While in other cases, the patient as a reference of, okay, in the past, the self had the following characteristics, and today it has these characteristics, like I have pain in my shoulder, and this difference is now my particular symptom.
Yeah, so it is very difficult. I am not used to reason in these terms, but certainly I would say that the self is affected.
Mm-hmm. Right.
The self pre-drug is a different thing than the self post-drugs or during drugs.
Mm-hmm. Okay.
So the possibility exists then that the people that are taking a significant amount of these drugs on a regular basis, but not experiencing the same impact on these brain circuits. So they're therefore able to continue to live their life more or less and to take and leave the substance more effectively than somebody who's addicted. So they're not meeting the criteria. I mean, in your studies, do you use control groups who are cocaine users but are not, or alcohol users who are not recognized as addicts?
No, yeah.
Yeah.
My experience with humans, in spite of the fact that my degrees in medicine, I never did clinical work. I always did the Roberts work, electrophysiology. So it is simply by 7-8 years ago that I began with these human studies. And another thing is the point that we touched briefly this morning is not easy.
Yeah.
And patient recruitment is not an easy task. And it's very time and effort consuming and frequently frustrating. So to find a group like that you were saying, it will take months and months of work.
So, but it's before we kind of conclude that the differences we're seeing in the brains of people with addictions from those of the controls who are not drug users, it's possible that some of those differences may predate their addiction and that they may already have a predisposition or a genetic something about the personality which is reflected in some of these findings.
I think that a portion is only in that way. I think that there are several factors that contribute to the full-blown syndrome. In some case, maybe that is predisposed.
Yeah.
In some other case, even if it's not predisposed, but it comes across the drug situations and things, you may become addict, even if you were not.
Yeah.
So there is not a single thing that you can identify and say, okay, I know why you are getting addicted.
Mm-hmm. So now we have a bit idea of the sort of the phenomenon that we're looking at of addiction, right?
Yes.
And it's different, let's say, medical, psychological, and also biological aspect.
Yes.
But now in your research, you have dissected that down to a set of very specific questions, right?
Yes.
Along what are the changes to the dopaminergic system and its targets?
Yes.
This has really become, over many years, the main research trajectory that you have followed, which I think is also very much representative for the field, if I Right? These are very some of the targets that people look. So the first of experiments you looked at let's say what's the effect of drug use and of withdrawal of drugs on the response of the dopaminergic cells.
Exactly.
And you report actually rather, and also that's confirmed by other experiments, rather dramatic impact on also the baseline activity of these neurons, right? So the main users of actually different types of drugs.
Yeah.
That in some sense might even be not that related, right? It can be alcohol or cannabis or opioids.
Yeah.
Right. In all cases, you see a reduction in the baseline
activity. Yes.
So how do you explain that? Where does that come from? Why is the tonic activity reduced?
A very simple way of providing a possible explanation relates to the acute effect of the drug. All drugs of abuse, they do increase the activity of the dopamine system. Once you take them chronically, there are various neuroplastic effects that take place over time. Tolerance, sensitization, reverse tolerance, there are several. In brief, what is happening is that the system, the dopamine system, is adapting to the new situation in which in the environment there is always a molecule that stimulates its activity. So when you take out this thing, the dopamine system becomes orphan. Actually, the drug may work as a constant pusher of the system. You take out the drug, and the system has adapted to a lower level to compensate for the exogenous drug that is demanding an increase in activity. Dopamine neurons are also neurons that are very energy demanding. So to make a dopamine neuron firing is more costly in terms of energies.
Why is that?
I don't know. Paul Bolam has done these studies. He's an excellent, as you know, neuroanatomist. They are very branchy neurons.
Yeah.
They have a huge number of
so the
baseline
baseline
laterals,
right.
and but I remember that the conclusion was that is from an energetic standpoint. To keep it going, you require a lot of fuel.
Right. But that means at the first stage of the process, you essentially describe this as some homeostatic system, right? It's self-regulatory. Now I'm in some sense overwriting an intrinsic drive of the system with an external cue, which is a drug, right? I'm overdriving the system, so it starts to downregulate.
So the system goes down to accommodate for the drug. And if now you take the drug, it goes to a lower level.
Okay, and those mean if you then are not exposed to the drug long enough, you should sort of bounce back to this initial baseline. Is that true?
Yes.
Okay, so it's like a self-regulatory system,
exactly.
And the drug now sort of co-opts that system and it readjusts.
Okay, cool.
So, are we optimistic then that you can make a full recovery, or do you have some long term?
With TMS, you mean? Or?
No, I mean, just generally, if you were to stop the drug. And
if you stop the drug at the very first period, it is a painful period.
Yeah.
And we know that. So we know it for each single drug.
Yeah.
But it is different.
But is over 6 months, say, are you back to normal? Are you indistinguishable from a control?
Okay. This is almost a joke.
Right.
But it is said that the diagnosis of a fully recovered addict, you make it only when he dies.
Right.
He's like a schizophrenic.
Yeah.
You know, he ain't fully recovered. Now he's dead. So this is almost a joke, but to tell you, it tells you how difficult it is.
So the answer is
you can say, this guy is 10 years that is not taking cocaine anymore.
But Marco, there's something though, physiologically, physiologically, do the neurons you measure from return to exactly the same baseline level? Or do they go back to a somewhat different baseline level? That means as if there's a memory in the system, right?
For the last question, I would say that there is a memory in the system.
Mm-hmm.
There is a cellular memory as in every cell. But this is my conviction.
Right.
There is only a memory. Let me go back to the first part, and it escapes me now.
No, so I was starting to unpack the whole addiction syndrome by really now zooming in of this dopamine.
Oh yeah. If it goes back to the pre-drug level,
yeah.
Yes, it will go back. And we have examples. We discussed this morning at the lecture. Opiates. You have an opiate-dependent individual. Fighting rate goes down, dopamine release goes down, TH goes down, everything goes down. Then eventually it will come to normal level, pre-drug level, in 2 weeks. Remember that we are talking about rodents. Now, the time scale is different. So, but in rodents, in rats, in 2 weeks, more or less, you have a system that is apparently working as it used to. And we did this paper. We did publish the paper. If you do administer morphine now to an opiate-dependent individual, the reaction to morphine will be magnified enormously as compared to the first shot of morphine in a, let's say, undrugged individual, in spite of the fact that they have the same basic firing rate. So this experiment tells you some more. Yes, is going back the mechanisms that sustain the spontaneous firing rate. But perhaps not every mechanism has gone back to normality. It is known, for instance, that when they recover, one of the things that comes back to normal later than others is the sleep-wake cycle. They don't sleep well. Although they may be 8 months without taking drugs. And they have fixed the diarrhea, the sympathetic imbalances, the various things. Pain, kicking the monkey, and all that kind of things. In spite of that, still they don't sleep well. So every sign and symptom, they have their own time course.
Right.
Okay.
Well, it also indicates that you already indicate, or no, maybe not. You have to look also beyond dopaminergic system. Right?
Exactly.
Global change.
Yeah.
But so, what was it? What happened next? So now we have a huge impact on the baseline firing of the dopaminergic system. And then he showed, in also very great anatomical detail, that in turn has a huge impact on the targets of these dopaminergic cells.
Yes.
Right? That immediately the spine density along the targets of these dopaminergic cells, and you looked at in accumbens, so your ventral striatum, but supposedly it would happen on any cell that's targeted by these dopaminergic
Elsewhere,
right?
Yes.
So the dynamics of this these changes. So if I lose all my spines, it also means I'm losing my synapses.
Yes.
So is there any specific pattern to that, or is it a very non-specific effect?
We didn't find it yet.
Because that would mean that essentially it's a massive disconnection suddenly. There's a dramatic disconnection in the nervous system.
Yes.
Is that how you interpret it?
Yeah.
Mm-hmm.
In different words, I expressed the same thing. You are expressing it in very nice words. There is a massive disconnection.
So, if you would have to guesstimate, so if Tony pulls out the gun again, if you'd have to guesstimate how much of the circuit of the brain is disconnecting as a result of this, Just rough guess.
Rough.
What do you think? Like 1%, or is it like 40%, or is it even higher than that?
Well, I don't know, but but between 1% is more.
No.
It's more than 1%. It's 40%.
No.
Then if you say it's 40 or 80%, I would probably say 40.
Mm-hmm. Okay.
It's difficult to put these things in numbers.
No, but the key
But
thing
this
here-
connection, believe me, the behavior changes.
Right.
The
No, that's the point,
behavior
right?
changes. The best way to have a description, but not a scientific, strictly scientific description, is to ask a mother. Ask a mother that has a child that is taking drugs. She would tell you, this is not my son anymore.
Mm-hmm.
The whole behavior changes. It's affect the relationships with loved and unloved, sleep-wake cycle, feeding, everything changes. Everything changes.
Right.
More or less, it's like if someone would be interested in opiate addiction, I would never suggest him to read one of my papers, but I would suggest to read Confessions of an Opium Eater by Thomas de Quincey.
Right. Exactly.
Or if you want to study memory, you don't read Rob Malenka, but you need first to read the French guy. What's his name? Now escapes me.
Mm-hmm.
La Recherche. All'ombra della fanciulla. Proust.
Ah,
Marcel Proust.
Yes. Mm-hmm.
Madeleine, the Biscuit. You get the idea of what memory.
Right. So we have a disconnection syndrome. It's interesting, right? Because in some Alzheimer's disease is also described as a disconnection syndrome.
Mm-hmm.
So in terms of the symptomatology, would you think overlap between addicts, chronic addicts, and an Alzheimer's patient? Like you have the hyper emotionality, you have a lack of cognitive control. Are these overlaps explored, or this is like just waking?
I never thought about that. I thought about the parallel between psychostimulants abusers and schizophrenics, for instance. I thought about cocaine addicts, you see this, and paranoics. Never thought about Alzheimer's.
Mm-hmm.
His capability are not great. He knows how to solve a problem. He can do an abstract thinking. He can solve a puzzle. Actually, he solves puzzles every day because he doesn't have money, and his problem every day is to get money, to get high, and then to get money again. And these are big puzzles when you don't have money. So they steal, they do strange things, but their capacity to reason is not touched.
Mm-hmm. But not totally.
Or at least in some part.
I mean, one of the we just mentioned, one of the knock-on effects is on the D2 receptors in this, right? And you discussed it at length. So just to be clear about what the effect is. So what happens is that the overstimulation of the dopamine neurons by the drug is flooding the striatum with dopamine, and that's causing a reduction in the D2 receptors. Is that correct?
Well, I don't know if there is a causal role.
Okay.
I don't know if the dopamine receptors are decreasing in number because there is a lot of dopamine, or by an independent mechanism, which goes in parallel.
Right.
It could also be a neuroadaptive mechanism, as you are more or less suggesting. Lots of dopamine. Let's down with this. It could be. But these are possibilities. Plus, they are very academic possibilities, in the sense that if you are looking for a therapy, why is that? or there is another reason, what I have to do is to fix that number and take it back up as it was.
Yeah. Well, I mean, I think if it is an adaptation, then you would hope that that would again correct once you take out the excess dopamine. If the dopamine cells go back to firing at the normal levels, then you would hope the D2 receptors would also recover to their pre-addiction levels. So
yes,
but we don't know. That's still an open question.
Yes, yes.
Would you expect any kind of specificity with respect to different receptor types, or you think it's a very non-specific effect?
Within the dopamine system, non-specific.
Okay.
Although there is some consistent literature, for instance, in rodents, that tends to give to the D1 receptor a relatively major importance in rodents. In humans, so far cannot be studied because there is no label.
Mm-hmm. Right.
There is no radioligand. But Richard Morris said, and we did it ourselves also. And the mechanism in the population of the medial spiny neurons can roughly be divided into two categories. One, that is the medial spiny neuron that projects back to the substantia nigra pars reticulata. And these neurons, they do contain predominantly D1 receptor. Then there is another population which projects to the pallidus and then comes back. Okay, these are called the direct and indirect pathway. Virtually every study will tend to bring in the direct pathway. So you can block with SCH, which is the dopamine antagonist, and we did, as I was describing this morning, if you give L-DOPA to rats, you will have the spines growing back, you will have again your LTD mechanisms, and you will have also memory, the rodents performing well in emotional memory tasks.
Mm-hmm.
This can be blocked by SCH, but not by Sumpiride, which is D2 antagonist. And this is really invoking a D1 mechanism.
Mm-hmm.
But this is all.
Okay. But if there's a differential effect on the direct and indirect pathway, then this again would imply that there's a modulation of executive control system, right? Because they will depend on these pathways again for the kind of competition that plays out at this cortical level.
Yeah.
But now, so when we move from rats to humans, because this is in the end what you looked at, there was... So what made you believe that the transcranial stimulation could actually help you to resolve the addiction problem? What are the pieces of the puzzle that gave you confidence that this even made sense to do?
To resolve the puzzle is certainly an overstatement. We won't resolve the puzzle. The transcranial magnetic stimulation has two main advantages. The very first one is its physiological nature. You're using a stimulation. Let's forget a moment about electromagnetism and these things that are very confusing for some people. You are stimulating the cortex. You are able to modulate cellular activity in the cortical layer. This aspect has to be contrasted with what you have available in the field today. For cocaine, zero. There is nothing. There is not a single molecule. Why you have an opiate addict, you will say, okay, There is nothing else to do. Take methadone. Okay? You are tobacco dependent. Here is phenytoin, nicotine patches, gums. You have several therapeutic approaches. For cocaine and psychostimulants, there is nothing. So this is the first part. The second part, we spoke about this also this morning. The second part is this lack of possibility, of therapeutic possibility, pushes the psychiatrist to find something to give to this guy. And the standard things are antidepressant. Oh, he's taking cocaine because he's depressed. It's obvious, Antidepressant, anxiolytics, and mood stabilizer. Now, as a pharmacologist, I am fully aware that while we do know the pharmacology of antidepressant, we know much about anxiolytics and problems and toxicology of this and that. And we also know about the pharmacology of the mood stabilizers, whatever that means, because we don't know nothing about the pharmacology of these three molecules in a 50 years old individual, which is risking heart attacks, which takes blood lowering blood pressure pills, and eventually even other things. So this combination of factors compared with the TMS tells me, go ahead with TMS. At the very worst, you won't do anything, but at least you won't do damage.
Right.
While the drugs, they do damage.
So you're having a very localized effect with the TMS, whereas rather than the systemic effect, which has got to be positive as well.
Exactly.
But I mean, what's interesting about the TMS effect is that, as you said, you can't specifically localize one area of the cortex. So you could be rewiring some of the associations that we have in the frontal areas. And that could be a positive thing, and that you may be unlearning this link between dopamine release and alcohol or cocaine, and you may be learning something about dopamine release and TMS, but that's it may be a better association to have. So that this thing, when you see alcohol and you have to drink it, or you see cocaine, you have to have it. Unlearning that would be really powerful.
Exactly.
And perhaps that's one of the benefits of this treatment.
Exactly. This is also possible. We are speculating. If we are allowed to speculate.
We are in these interviews. We can.
Exactly.
What's that?
We can hear. We can speculate.
That's why we're here, actually.
Yeah. The TMS, there are studies, for instance, which are showing the TMS in certain cases and in certain areas of the brain are inducing connectivity strengthening. So with those methods that visual imagers do now, tractography and all these kind of things, they are able to tell you that after a stimulus, you have this bundle is thicker, thinner, and things like that. And these things are emerging. They also appear to be frequency dependent. So you can increase or decrease or modulate not only transmitters, but the real structure of the neuron. Okay? There are also other reports in the memory field which indicate that the TMS is able to modulate dendritic spines, the number, the shape, in vitro, in vivo. Once again, these are not things that are established and well established, but they let you speculate.
Well, there are two things going on. One is, as you say, a direct effect that TMS could have on the sort of wiring of the brain, maybe the learning effect. There's also the effect that the releasing the dopamine has, because of course dopamine is a very powerful learning signal.
Exactly.
So during the TMS episode, the dopamine release is stimulating you to learn something,
Exactly.
which is possibly to have positive associations
Exactly.
around TMS if
Exactly.
it's the dopamine release experience is pleasurable.
Yeah.
But this is also the weakness of the method.
Well, this is a
Because-
risk of it. Yeah.
So isn't it really of a great priority to find also a way to contextualize the stimulation, that you really allow this brain to reconfigure in a way that is less risky. So if you do
Yeah.
a TMS stimulation, you know you're going to drive dopamine, you're going to drive all sort of associative learning processes. So maybe it's important that it happens in a context that is like a healthy, normal life.
Yeah.
So have you considered that? Have you included that? Because now you are conditioning, and so you are conditioning people to
We are
really
conditioning people.
love the
Yes.
TMS device, right?
And again, we are looking at all these things, and I appreciate very much this very stimulating talk because it gives you more ideas. The incumbent problem you have always, every day, with each one of these guys is, are you taking cocaine or not?
Mhm.
If he's taking cocaine, you see, with those that are not taking cocaine, then you can go deeper in the conversation and ask those questions we were saying. But so tell me about cocaine now. Here, you see, this is cocaine. What do you think? How do you feel? But only a portion. But our target
Mhm.
is to lower the drug intake.
Of course. So one thing he
And
considered,
then it will come with time.
well, there are interesting approaches that look much more at associative processes, right? They try to dissociate the drug-associated stimuli from the addiction. So you have simple conditioning paradigms, so behavioral therapy paradigms, where you try to dissociate alcoholics from beer bottles and wine bottles.
This is what we do.
Right?
This is
And-
what we do.
Okay, and in your case, you can do something similar, right? Because now it's not about dissociating; it's about forming new associations. So you
Exactly.
project people into a
Something.
context that is supposedly the healthy living context,
Exactly.
within which they are getting then conditioned without seeing the TMS device.
Yeah.
So that would suggest that you have to go to things like virtual reality to do that.
This is another thing that is next
Mm-hmm.
to be investigated.
Very good. That would be very good. So we look. So you found a way to reactivate this under activated dopamine system. Through that, you're able to reactivate the targets of the dopamine system. You allow the circuit to rebuild, right? And in some sense, also one of your most recent papers, you also showed that it led to reduced cocaine intake.
Yeah.
Correct. No.
Correct.
Would this just generalize without further adaptation to any other addiction? Like, can we go for alcoholics, do the same thing?
Only in theory. Only in theory.
Would you believe it could?
It could, but I'm also aware that drugs are not the same. Although all of them, they do increase the dopamine transmission and they do decrease dopamine transmission after withdrawal. There are drugs that are more difficult to drop, like nicotine, for instance.
Okay. So which one? So you think cocaine is actually one of the easier targets?
I would say,
Okay.
absolutely, I
Mhm.
would say that.
Are there drugs that you think are completely beyond this method?
No, I'm not a pessimistic individual.
Okay, good.
Yeah,
That's good. But then, so now we can open up a little bit, right? So we already indicated and discussed that this is very much dopamine centric, right?
Absolutely. I
So-
admit that.
No, and that's fine, right? Because you need controllability, so we have to start to reduce complexity, and then you came a long way. It's fantastic that you see that a non-invasive method
Yes.
actually have impact on drug intake. It's
Yeah.
incredible, right? But what other systems would be on your wish list to start to include now in an understanding and also intervention for drug addiction or to counteract drug addiction?
What we are trying to do still very difficult, very time consuming. We are trying to do mainly two things. One is to couple the studies with functional magnetic resonance. Before, after drugs, Q inducing, there are many things. In the wish list, you're asking me my wish list. Huh? So this is the dream book, we call it.
Good.
The other thing are the protocol. We would like to investigate better, like theta burst, to see if beyond the obvious advantage, the practical advantage that while one of these treatments with 10 hertz will cost you 27 minutes, theta burst will cost you 3 minutes. Beyond this, if it has a different effect on the drug intake, first of all, and eventually in all those cognitive functions that can be measured, or measured is a strong word, estimated through the tools we have, Tower of London, Iowa gambling, whatever, in the wish list.
Right.
I hope that God will keep me
Going
in a life.
But now with the current TMS protocol on the cocaine users, how much of a reduction can you accomplish? Right, it's not that they go to zero. So what's the modulation you get?
Okay, we have, first of all, we have 70% people that they do stop in the first month. Okay? This is more or less the success rate. We don't have data other than those published in the long range, and this is the most important part.
Yeah, exactly.
There's 6, there's no even 6, 9, 12 months. 9, 12 months. The relapse rate in our case is around 70%, and normal addiction treatment service is around 98, 99. So, better than nothing.
No, it's a substantial impact. Right?
Substantial, yeah.
Tony.
Yeah, we were talking about the sort of broader implications and uses of TMS. So there is evidence that nicotine, even cigarette smoking, can lower risk of Parkinson's disease. So, and I don't know what the mechanism of that. Perhaps you do, and that involves stimulation of dopamine cells. So, is there possible therapeutic benefit in Parkinson's for the TMS?
In Parkinson has been tried and is being tried for several things, but not for the progression of the disease. So you try to reduce tremors, you try to reduce other aspects of the syndrome.
Yeah.
The people in general believes that Parkinson is a lack of dopamine, and so it gets cured by administering L-Dopa. Unfortunately, this is not the case.
But what do we know about the mechanism through which nicotine may have a protective effect?
Well, nicotine pushes dopamine neurons.
Yes.
So it could easily be.
Yeah.
On dopamine neurons, you have nicotinic receptors. So when you take a puff, it will go here, and the dopamine neuron will fire more. If you consider that you observe clinically Parkinson's, when the number of cells has fell 60% or something, nicotine can help to push those neurons to make you moving. But this is a very, how can I say?
But it's more, I think, the evidence is that it's preventative, so people are less likely to.
Prevents?
The people are low risk of Parkinson's.
Smokers?
Yes.
I don't know.
Yeah, that was the
There
claim.
is-
Mhm.
I don't know.
Mhm.
No.
Right.
No.
But so, what other neurotransmitters would you put into the mix? If
I told you, CRF.
okay, so CRF.
Corticotropin releasing factor.
Okay.
CRF has a behavior that is just the mirror image of dopamine. Dopamine goes up, CRF goes down, and recently the people at Scripps, Olivier George and George Koob and his group in Vendruscolo, a number of people, they are very big and prominent group in the field. They found, in spite of the fact that George Koob is an anti-dopamine guy in general, but very nice, they found the link between CRF and dopamine neurons. They did studies in rodents and humans post-mortem, and they combined a nice and steadily standing story.
Mm-hmm. Okay, that's the new frontier.
In pharmacology, yes. I prefer to think that TMS is the new frontier.
Okay. But now you also made quite a strong statement about the whole opioid epidemic, right, that we're facing now, especially in the US. Right?
It will come here.
Are you sure about that? We already seen it
I would love to be wrong.
Okay, yeah, of course. I understand.
I would love to be wrong, but I fear there will be.
Mm-hmm.
Because in that case, there is a portion of medical malpractice first.
Mm-hmm.
In the US, they are very easygoing with opioids.
Mm-hmm. So
you find over-the-counter pills for sore throat with codeine. Codeine is an opioid. It is an antitussive drug. It is employed as an anti-coughing drug.
Mm-hmm.
But an addict immediately understands that instead of taking one pill, he will take 5 pills and he will get high.
Mm-hmm.
So this is one problem. The other problem is it's not codeine, nor is, it's heroin for that matter, but are the fentanyl derivatives. The smugglers, I don't know, we go now into the chronicles of drug barons and Escobar and El Chapo. I don't know if you follow, but the Mexicans, to make it very brief, the Mexicans used to be the mules of the cocaine that was coming from Colombia heading the United States. The Mexicans are not anymore the mules. They are the directors of all operations. And they discovered that illicit labs can make amphetamines, methamphetamines, and MDMA, and fentanyl derivatives. So the US have been invaded by this very cheap, powerful drug. And many people that get refused by the physician, they go to the street and with $5, they buy a shot of fentanyl and he dies because the drug is incredibly powerful.
But how do you see the role of, let's say, the pharmaceutical industry in that and the standard medical practice in the US? Because in some sense,
they push it. They push the physician to administer it.
Mm-hmm.
They do what they do everywhere. I don't want to talk badly about the companies because, but I know for a fact this is a true thing.
Mm-hmm. So you think there's a market, just commercial market forces at work driving this epidemic?
Contributing. Certainly not putting obstacles.
Mm-hmm. Right.
Certainly not putting obstacles. I would never dream of accusing Big Pharma of triggering this thing. But certainly they don't do nothing against it. And we know that they do anything to sell their compounds.
Right.
An opiate cannot be sold over the counter, to make it brief.
But
In
no,
Italy is not sold. I don't think it is sold in Spain. And I don't think it is sold in Europe, throughout Europe. You know.
But now, do you believe, so earlier we talked about cocaine and other drugs of abuse, where you said it was something like, if you have 100 users, maybe 20 get addicted, something like this, right? That was it.
Exactly. More or less.
If it's fentanyl, would fentanyl the number be higher? Or it would still be the
I
same?
don't think it will be higher. You will get more deaths.
Oh, absolutely.
Because they know this thing already happened. In the 80s, there was a thing called China White in California, and there were numberless deaths in San Francisco and Los Angeles. Oh, gee, this must be an opioid overdose. The guy had the needle here. It was cyanotic, blue. And so depression, respiratory depression, they went to see if there were morphine metabolites, and morphine could not be found. After some time, they found fentanyl. Yes. China White was the name, the street name of the drug. It was composed by fentanyl and meperidine, which is an opioid that has mostly peripheral actions. So the addict feels that, and he perceives the action, the peripheral actions. And they were selling this as if it was heroin. They don't say this is fentanyl. This is very good. Give me $10. Be careful, huh? Be careful, because this is very good. So somebody was not careful. And many people died. It is occurring exactly the same thing. The use spreads, and many more people will die.
Okay.
62,000 is not bad as a number, unfortunately.
That's scary. Yeah, that's really scary. So Marco, we're close to the finish line.
Okay.
And so we made quite a tour also through your career, which started quite a few decades ago by now, right? In this whole business of addiction. So you are a dyed-in-the-wool neuroscientist and addiction researcher. So if you want to learn from your lessons, or want to learn from you and your experience, what would be Marco's law we should adhere to understand how the brain works?
The brain works? Jesus, this is tough. You should help me.
We give this question to everybody.
Pull out the gun, Tom.
No, I don't consider myself.
Your advice to other researchers.
Your students, right? Your students. What's the rule you would give them? What's the codex that you would give to your students?
To my students, to keep going in neuroscience.
Yes.
The most important ingredient
to solve the problem. Yeah, to make progress.
Two things you need. You need an endless intellectual curiosity and enthusiasm. Enthusiasm. You don't need to be rich. You don't need to be nothing. You don't need to be smart. The brain is a smart organ. The brain, if you make it working, it will work. And the more you make it working, and he enjoys that. This is called enthusiasm. I would say I try to transmit this to the youngsters.
Right.
Curiosity and enthusiasm. Curiosity could be an elixir of long life, because I think we begin declining when we say, oh, I know that already. When you believe that you have learned whatever is possible to be learned. So it's nice to think, no, I didn't learn everything. Otherwise, I'll be dead.
So how do you protect then your own curiosity and enthusiasm? How do you protect it?
With TMS, doing something new, moving from physiology in rodents to physiology in humans.
So novelty, right?
Novelty seeker. That's absolutely.
But then the last question is that, so Tony still wants to go to Sassari. He hasn't been there yet. You guys have been in Sardinia lots anyway, right?
Once, just once.
Okay. The 4 years from now, Tony will come visit your lab
Oh, sure.
with a little notebook
Okay.
to check whether you actually had falsified your core hypothesis, and you're going to share with us today. So what's the key hypothesis you want to see tested in the 4-year time frame in your program?
You know what I'm trying to do? I'm trying to develop a way to measure or to estimate dopamine in the human brain in the living human brain, which will not be PET scanning, nor will it be functional magnetic resonance. But because I don't have those opportunities, it's not that I don't want. But we are pursuing the electroretinogram, it's called.
Mm-hmm.
There is dopamine also in the retina, as there are D1 receptors. And there are studies which have indicated that the blue cone wave apparently is not mediated by dopamine contributes to this. And this has been seen in cocaine addicts, and it correlates with the dopamine metabolites in the CSF. So perhaps with the electroretinogram, which is a very simple thing to do, in 4 years I might have some results for Tom if he counts, and if you count too.
Wonderful.
So for you, it is much easier with a Sardinian wine.
So Marco Diana, thank you very much for this conversation.
The CSN podcast was produced by the Convergent Science Network of Biomimetics and Biohybrid Systems, a project funded by the European 7th Research Framework Programme. For more interviews, recorded lectures, or upcoming conferences in the field of biomimetics and biohybrid systems, go to csnnetwork.eu. And thank you for listening.